In this section, we're talking about applications of linear systems of equations. The goal is to solve application problems using systems of two equations and two unknowns. Before we jump into any particular problem, let me give you a four-step problem-solving technique. It's not the holy grail of problem-solving, but it's helpful. And actually, the way I phrase it here, actually the way Polya phrased it, he was a guy, lived a while back, and he thought a lot about problem solving. It can apply to life as well as problem solving. So the first step in problem solving, Polya's first step, is to, and this may sound like, well, duh, but it's actually really important. It's to read/understand the problem. If it's actually a word problem that you're solving, you have to read it. If it's a problem in life, you just have to understand what the problem is before you can solve it. So many of us don't, especially in math, we just try to start solving it. We're not really sure what we're doing, right? We just start writing X's down, and we're not really sure what we're doing. It's really important in regards to a math problem to maybe read the problem a couple of times to understand what it is you're looking for. I'll go back to the beginning in a second, but let me list these steps for you. The second step is to develop a plan to solve the problem. Again, well, duh, we need to do that, but sometimes students don't do that in math. They just start making equations and hope it works, right? But that works for real life too. If you want to solve a problem, you need a plan. You need to execute the plan, carry the plan out, right? It doesn't mean kill the plan, but execute the plan, carry it out. And then 4, one of the most important steps that we often don't do is we don't look back. We don't check our answer, and I don't mean by plugging back into the equations. I mean, does the answer make sense? So look back. Step 4, look back. Check the answer by saying to yourself, does it make sense? Okay, so a little bit more about that first step. In that first step, if it's a life problem, you can't necessarily call anything X if it's a problem you're having in life, right? But if it's an algebra problem, in order to help you understand the problem, you can define your variables if necessary, or if possible, draw a diagram, right? If it's a geometry problem, you can often draw a diagram and label your unknowns within that diagram. So these are both things you would do to help you understand the problem. In step 2, your plan is going to be to solve the equations. It might be one or more equations, so I'll put that S in parentheses. In this section, it's going to be 2 equations, 2 unknowns. Step 3, you're going to solve the equations, right? Execute the plan, solve the equations, solve the system. And step 4, yeah, okay, you can look back and check your answers in the equations you created, but more importantly, answer the question, does your answer make common sense? If you're looking for the width of that door over there, and you get an answer that the width is -3 feet, does that answer make sense? No. I don't know what -3 feet looks like. There are situations where a negative can make perfect sense. But when you're finding the width of a door, usually I don't see many situations where that would make sense, unless you're coordinatizing it in some weird way. So does your answer make common sense? Look back. Does it make common sense? In the first example, the measure of one of the small angles of a right triangle is 14 more than 3 times the measure of the other small angle. Find the measure of both angles. Okay. So let's think about it in the context of Polya's 4 steps of problem solving. First step is to read the problem, but not only read it, understand it, right? So we're looking for a couple of angles. What could you do to help you understand the problem a little bit better, though? You can draw a right triangle. What's a right triangle? What's special about a right triangle? Has a 90-degree angle. So we're going to draw a right triangle. I don't quite have a right triangle shape, but I can make one. So let's draw a right triangle. So this guy, we use a little square right here. That's the 90-degree angle, right? So when possible, draw a diagram. If it involves a geometric figure, you can draw a diagram of it. So we know that little angle with the square inside it is the right angle. And then we've got 2 other angles, right? They don't have to be the same measure, do they? So it looks to me like this has to be the bigger of the two angles, right? So I'm going to call that guy y, and I'm going to call the smaller of the two angles x. Although, does it really matter which one's which? Not as long as you set up your system correctly, it doesn't matter. All right, so we want to solve this using a system of two equations, two unknowns involving x and y. You guys might be able to figure out the answer by trial and error, but that's not the point of the problem. I usually give you questions that have nice whole numbered answers, or maybe like something 0.5. Pretty nice numbers to work with. In reality, you don't get nice numbers. So the nice numbers are so that you don't, the arithmetic's not the center of it, right? So even though you could maybe do this problem using trial and error, that's not the point, and you're expected to use a system of two equations, two unknowns. And you know, I could give you the ugliest problems with the ugliest answers in the world, but I don't want to do that. I want to focus on the method. So we give you problems with answers you could probably find without algebra. But the point is, later on, I'm giving you a method to solve problems you couldn't solve any other way. You couldn't solve by guessing and checking. Okay? So follow the method. The method is as important as the answer here. Okay, so what has to, okay, if I want to set up a system of two equations, two unknowns, what has to be true about x and y? Can you think of one equation involving x and y? I mean, like maybe if you add them together, what would they have to equal? That's true. That's true because, okay, what's the sum of the angles in a triangle? 180 degrees. Now, I would make this claim, you could simplify it a little bit. 90 degrees is taken up by this angle, right? Oh, so there's only 90 degrees left. So what would x plus y equal? 90. So there's a nice simple equation, 90 degrees, right? But as you know, we need another, if we have two unknowns, we need another equation to help us solve it. So then we have some information. We have that the small angle is 14 more than 3 times, oh, that should say times right there, is 14 more than 3 times the measure of the other small angle. Find the measure of both angles. We have to translate from words to symbols there. Okay, first of all, what does 14 more than? What operation does that translate to? Addition, right? 14 more than. And then what does 3 times, that word times, what does that translate directly to? Multiplication. Okay, so we're comparing y and x. And the way I set it up, x is the smaller angles. So in order to get an equal statement here, what do I have to do these operations on, the x or the y? In order to get an equal statement between these two, you have to perform these operations on the smaller angle to get it to equal the bigger angle. Does that make sense? Okay, so I'm gonna add 14 to 3 times x. That's really what it's saying to do. And then that should be equal to the bigger angle. Does that make sense? Any questions on how I did that? Okay, I've got a system of 2 equations, 2 unknowns. Technically, this is a 14 degrees also, but you can leave off the units to the end of the problem if you want, so that you don't have to worry about units. Okay, now you have in the past learned about 2 different methods of solving systems of equations, substitution and elimination. Can anybody remember which method this one is built for? Substitution. Okay, in substitution, what you do is if necessary, you get one of the variables by itself, right? One of the unknowns by itself. And then what does that allow you to do? You can substitute in what y equals in this case in terms of x into the y, in for y in the other equation. That's the substitution method. Does everybody remember that? No? Okay, at least you're being honest. But that is the substitution method. We substitute so that we get one variable and we can solve the equation, right? So, okay, so that means, and this is just for emphasis, but where that y was in the first equation, I'm going to substitute in what y is equal to, 3x plus 14. And then we still have the equals 90. I don't really need the parentheses there in this case, but in other cases you would need it there. Like if you had a 2y, you would need to distribute the 2. So that's a good habit to be in. Put the thing you substitute in parentheses. Easy enough to solve that little equation, right? Combine like terms, how many x's do you have? X plus 3x makes 4x plus 14 equals 90. Help me out here. So 4x is equal to 76. If you subtract 14 from both sides, right? Notice I didn't show the minus. If you want to show the minus 14 from both sides, you can, but I'm going to just say 4x equals 76. Okay, then what do you do to both sides? Divide by 4. I'm also going to skip that as well because it's nice just to go from 4x to x equals. What's 76 divided by 4? It's got to be 19, right? 19. So are we finished? No, we also need, it says find both angles, right? So we need y. What's the easiest way to get y? Now, which equation do you want? You could plug it into either equation, but which one's easiest? The one that's already solved for y. Right? Because it's just arithmetic. You plug it in, do the operations, and you got y. So we get y is equal to 3 times 19 plus 14. Well, what's 3 times 19? Got to be 57. And then 57 plus 14? 71. Okay, so what would you say to answer this question fully? The angles measure (19 degrees), so put in the units at the end, and 71 degrees. Now, I didn't point it out along the way, so let's talk about Polya's 4 steps in problem solving. The first step was we read the problem, right? And then we drew a diagram to help us understand the problem. So this is really part of step 1. Setting up the system. Remember Polya's 4 steps in problem solving. Read, understand the problem, step 1. Step 2, well, we need to develop a plan for solving the problem, right? So our plan is to set up and then solve a system of equations, right? That's step 2. Step 3 is actually executing the plan, which is this part where we actually went through and solved the system. And then step 4 is to look back to see if your answer actually makes sense. Well, does x plus y equal 90? I mean, that would be a way to, if it didn't, that'd be a way to right away realize that, oh, something's wrong. So we have in this first equation the statement that x plus y equals 90. Does 19 degrees and 71 degrees equal 90 degrees? You bet. You could also check it in the second equation. And then you could check it for common sense things. Like, what if you had a negative 19 degrees? Something's wrong, right? Yeah, something's wrong. So no, these answers are fine. They seem very reasonable on a common sense level, and they do satisfy both equations.